Hello. Today we're going to talk about selection sort. First of all, what is selection sort? Selection sort is an algorithm that sorts a list by comparing all elements to find the smallest or highest number in the list. First, it searches through the whole list, then it will compare it to all the others until it finds the one it's looking for. Lastly, it will replace the number that it finds with its position number of where it's supposed to be. In selection sort, there are two parts of the list, the sorted portion and the unsorted portion. Selection sort puts elements into the sorted list until there are no more unsorted elements, which means the whole new list will be completely sorted. Consider this array, 5, 8, 1, 9, 2, with index numbers 0, 1, 2, 3, 4, index numbers respectively. First of all, it will set 5 to its current minimum value. Then it will compare that to 8. 5 is still the smallest number in this array so far. Then we compare it to 1. 1 is our newest minimum value, so we set that as our new min value. Then it will compare it to 9, and then compare it to 2. Now through this whole list, 1 is our final minimum value, and we have to put it into the position of 5. So we swap the position of 1 and 5 until it looks like this. So 1 is now in our sorted portion of the list, while 5 is in the unsorted. Now it will set 8 to the newest minimum value because it is the first element in the unsorted portion of the list. It compares it to 5. 5 is our new minimum value in this list, and 8 is not. So now we do that to 9. 5 is still the smallest number in the list so far, and then we compare it to 2. We set 2 to our new minimum value in this array. And then we have to swap the index numbers 4 and 1 because 1 is our first element in the unsorted list. Now 5 is our minimum. Even though we know it is the smallest number in this list so far, we still have to check it. So 5 compares to 9, compares to 8, and it realizes that 5 is still the smallest number in this list. Now we're checking for the position 9 and 8, or 3 and 4, lastly, the index numbers. So in the last part of the array, it will just check for 3, because there's no point in checking the last number since it will be already sorted. So compares 9 to 8. 8 is smaller than 9, so it will change positions and end up like this. So this is your final array. Notice that all these numbers are in its correct index positions because it has sorted through every single element. Here is a Java code example. Int I, j, and n. J being the variable we will use for our first for loop, and I being the variable we use for our second for loop. N is the number of items in the list. So the first for loop goes through the whole list and sets the first value in the unsorted portion of the list to the minimum value. Then for the next for loop, it will run through the whole unsorted list and check every single value. And inside that, it will compare the minimum value that you have right now, which is j, to the any new elements that are in the unsorted portion. So if the first position was your minimum, then it will check the second, and if that does not work, then it will check the third, and if that is the new minimum, then it will set it to your new minimum. And lastly, in this for loop, it will check if the minimum is equal to your j, because it could already be in its position already. If the minimum does not equal to j, then you will have to swap the position of j with the minimum value until we get the whole list sorted. So this keeps on running until the whole list is sorted. And the runtime for this is n minus 1 times n. Since it will give you n squared minus n, we take the biggest number, and the big O notation will just be O n squared. A real-life application for selection sort is sorting through a smallest of ages. It could be from youngest to eldest or eldest to smallest. And this is because selection sort is not very useful for large lists because of its O n squared big O notation. And this means that it will run the number of elements squared, which is not very quick because it's got to run through every single element and then check through all those elements. So that's why it's not very efficient for large lists.